Welcome to our deep dive into the fascinating history of mathematics. We'll be journeying through time, exploring how math evolved from simple counting to the complex systems we use today. And to guide us on this adventure, we have this really cool YouTube documentary. It's packed with aha moments, so get ready to be surprised.
Yeah, it's easy to think of math as something that was just like invented by one brilliant mind. But this documentary really shows how math was a collaborative process, developing over centuries and across continents.
It's definitely more interesting to think of it that way. Like, I always pictured some lone genius in ancient Greece figuring it all out. But where does this mathematical story really begin?
Well, believe it or not, it all starts with survival. Even animals have a basic grasp of mathematical concepts. I mean, think about predators judging distances to catch their prey, or birds, like keeping track of how many eggs are in their nests.
Oh, that's true. And my dog definitely knows how much slack he has on his leash before he can't reach that squirrel he wants to chase. But how did humans go from these basic survival instincts to actually developing mathematical systems?
Well, early humans, they really needed to understand the natural patterns around them. Think about the cycle of day and night, animal migrations, the changing seasons.
Yeah.
You know,
Yeah.
this need to predict these patterns led to the earliest forms of counting and measurement.
Wow. So those basic needs were like the seeds for all the complex math we use today. That's amazing. Okay, so the documentary jumps into ancient Egypt, right? I've always been fascinated by the pyramids. What kind of mathematical secrets do they hold?
Oh, the pyramids. They're a real testament to the Egyptians' understanding of geometry. The accuracy of their construction is just mind-blowing. And you know what? Their construction actually hinted at the Pythagorean theorem centuries before Pythagoras.
What? Really?
Yeah. They used a rope with knots at specific intervals to create perfect right angles. Essentially, they were forming a 3-4-5 triangle.
Oh, right. I remember that from school. A squared plus b squared equals c squared. So they were using this principle way before it was like officially a theorem. That's incredible. And they had a pretty good understanding of geometry beyond just the pyramids too, right?
Absolutely. We can see their problem-solving techniques in something called the Rhind Mathematical Papyrus. One problem asks how to divide 9 loaves of bread among 10 people.
Oh, that's tricky. How do you do that?
Well, their solution involved fractions. They divided some loaves in half, others in thirds, even 15ths. Pretty clever, huh?
That's pretty elegant. And speaking of fractions, the Eye of Horus is another example of how the Egyptians connected math to their mythology, right?
You got it. Each part of the Eye of Horus actually represented a fraction. Each piece was half the size of the one before it, a half, a fourth, an eighth, a 16th, a 32nd, and a 64th.
Whoa, okay.
This visual representation actually hints at the concept of a geometric series where each term is multiplied by a constant factor to get the next term.
Yeah.
You start with 1 and keep having it. 1, a half, a fourth, an eighth, and so on.
I see. So the Eye of Horus is like an ancient infographic for fractions. Pretty cool. But the documentary also mentions something about the Egyptians calculating the area of a circle with like amazing accuracy. How did they do that?
That's right. Their calculation was unbelievably close to the actual value of pi. Pi, remember, is the ratio of a circle's circumference to its diameter. What's interesting is that some researchers believe that the game Mancala might have contributed to their accuracy.
Mancala, the game with the little stones. What do you mean?
Yeah. It's thought that the strategic movements of those stones in Mancala could have given the Egyptians some insights into circular geometry.
Wow, so a game could have led to a major mathematical discovery. That's really cool. And what about those massive pyramids? They must have needed something beyond just geometry to build those, right?
They did. The Moscow Papyrus actually shows us that they had an early understanding of calculus through their formula for the volume of a truncated pyramid.
Calculus for a pyramid?
Awesome.
Seriously?
Yeah, and get this. It's a concept that was thousands of years ahead of its time in the West. Calculus deals with things like rates of change and areas under curves, which are important for understanding volumes of complex shapes.
That is mind-blowing. It really makes you wonder what other mathematical secrets those ancient texts might hold. So what's next on our mathematical world tour?
Let's head east to ancient Babylonia. They gave us a system we still use every day.
Oh, cool. Okay, let's dive into Babylonia. Babylonia, they gave us something we use every single day, and most people don't even realize it.
You're talking about our timekeeping system, right?
Yeah.
60 seconds in a minute,
Yeah.
60 minutes in an hour.
Exactly. It's everywhere. But why 60? What's so special about that number?
Well, 60 is what we call a highly divisible number.
Okay.
It can be divided evenly by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60.
Wow, that's a lot.
Yeah. So this made it super convenient for calculations, especially for a civilization that was really into astronomy.
Right.
They needed to track the movements of celestial bodies,
Yeah.
predict eclipses, develop their calendar, all that stuff.
So their math was driven by, like, a need to understand the cosmos?
Exactly.
That's incredible. And they had a pretty sophisticated way of writing these numbers down, too, right?
Oh, yeah. They had a place value system much like we do today, but instead of base 10, they used base 60.
Base 60. So, like, how does that work?
So think about it this way. In our system, each column represents a power of 10, ones, tens, hundreds, thousands, and so on.
Right, right.
But in the Babylonian system, each column represented a power of 60.
Okay, so instead of like tens, hundreds, thousands, it's like 60s, 3,600s, I guess, and so on.
You got it.
That's pretty wild. But wait, didn't they write on clay tablets? How did they manage a place value system with that?
Ah, good question. So they used a wedge-shaped stylus to make impressions in the clay, and that formed different symbols. And these clay tablets, they've actually survived for thousands of years.
Wow.
So it gives us this incredible direct look into their mathematical methods. We can actually see their school exercises, problems, and solutions.
That's amazing. Like we're looking over their shoulder.
Yeah, almost like stepping into their classrooms.
That's so cool. Did they have any favorite math problems? Like, are there any examples of, like, what they worked on?
Well, they seem to really enjoy problems that involved quantities. One example that's actually on the tablets is the cinnamon sticks problem.
Cinnamon sticks. Okay.
Yeah. So in this problem, they had to figure out the total weight of cinnamon sticks given certain proportions and weights.
Okay.
And they were actually able to solve this using equations even without algebraic symbols like we use today.
So they were thinking algebraically even before algebra had a name.
Exactly.
That's pretty impressive. What else were they really good at mathematically?
Well, they were masters of mental calculation.
Really?
Yeah. And this was partly due to their love for games, particularly backgammon.
Oh, backgammon. I love that game.
Yeah. So the strategic moves and all those calculations involved in backgammon really honed their mental math skills.
Oh, so it's like their version of a brain training app.
Exactly. But, you know, the documentary also mentions some controversy surrounding Babylonian math.
Right. The Plimpton 322 tablet.
That's the one. Some scholars believe that this tablet actually shows that Babylonians knew about the Pythagorean theorem, while others argue that it was just a teacher creating problems for students. It's a fascinating debate that kind of shows how we're still piecing together the puzzle of ancient mathematics.
Yeah, history is rarely a straight line, especially when we're talking about, like, uncovering ancient knowledge.
Exactly.
And speaking of knowledge, the Yale tablet shows they had an incredibly accurate approximation of the square root of 2, an irrational number.
Oh, yeah. That's a good one.
So that's pretty impressive.
It is. You see, irrational numbers can't be expressed as a simple fraction. So finding their approximations requires some serious math skills. It shows that the Babylonians were really pushing the boundaries of mathematical understanding.
They were ahead of their time. But for now, let's journey westward to ancient Greece, where math took a bit of a turn. Ancient Greece. Now, those are the guys who come to mind when I think about math.
They definitely made monumental contributions. But as we've seen, they were building on a foundation laid by these earlier civilizations.
Yeah.
What really sets the Greeks apart is this shift they made from practical math to a more theoretical understanding.
Ah, the birth of proof. So they weren't just satisfied with finding the answers, they wanted to know why those answers worked.
Exactly. And that's where the Pythagorean school comes in.
Right. Pythagoras and his followers.
Yeah. Now, while the actual figure of Pythagoras is kind of shrouded in mystery, there's no denying the impact his school had. They were completely obsessed with the properties of numbers and geometric shapes, believing that they held the key to understanding the universe.
And they're the ones who gave us the famous Pythagorean theorem.
That's right. But, you know, their journey to understanding math wasn't without its surprises. They actually stumbled upon these things called irrational numbers, like the square root of 2.
Wait, how can a number be irrational? That sounds a bit dramatic.
Well, an irrational number is a number that can't be expressed as a simple fraction of two whole numbers.
Oh, okay.
And you see, the Pythagoreans, they believed that all numbers could be represented as ratios.
Right.
So the discovery of these unspeakable numbers was a real shock to their system.
Wow. So math itself was revealing its own mysteries. And then there's Plato, right? He was really into geometry.
Oh, yeah. Plato was all about geometry. Remember that inscription above his academy? Let no one ignorant of geometry enter here.
Oh, yeah, I've heard that one.
He believed that geometry was the purest form of knowledge. the path to understanding the divine.
Wow, that's a pretty big claim. And he had this theory about the 5 Platonic solids, those perfectly symmetrical 3D shapes.
Yes, the tetrahedron, cube, octahedron, icosahedron, and dodecahedron.
I can never remember all those.
Haha, it's a mouthful.
Yeah.
But Plato actually linked these shapes to the elements.
Hmm.
Fire, earth, air, water, and even the universe itself.
So they were trying to connect math to the fundamental building blocks of the world.
Exactly. And speaking of connecting things, let's move on to Alexandria, the intellectual hub of the ancient world.
Alexandria, the city of knowledge. I've always wanted to go there.
Ah, Alexandria, a true melting pot of ideas and cultures. And this is where Euclid, one of the most influential mathematicians of all time, compiled and systematized all that Greek mathematical knowledge into his masterpiece, The Elements.
Oh, the elements. That's basically like the geometry textbook of all geometry textbooks.
You got it. It's a masterpiece of logical reasoning.
Right.
It starts with some basic definitions and postulates, and then builds up to complex theorems and proofs. It's been used for centuries as the foundation of geometry education.
Wow. And what about Archimedes? The documentary made him out to be like a real genius, even if he did have a bit of an obsession with spheres and cylinders.
Oh, Archimedes was definitely a true innovator. He made incredible contributions to figuring out areas and volumes, and you know what? He actually used methods that foreshadowed integral calculus centuries later.
No way.
Yeah. And his fascination with spheres and cylinders led him to discover this amazing relationship between their volumes and surface areas, and his results were super accurate.
That's incredible. I also heard he was quite the inventor too, right? Like, didn't he come up with some pretty impressive war machines?
He did. His inventions were used to defend the city of Syracuse against Roman invaders. But sadly, his mathematical brilliance kind of led to his downfall.
Wait, what happened?
Well, the story goes that he was so engrossed in a geometric problem that he didn't even notice a Roman soldier approaching.
Oh, no.
And when the soldier ordered him to move, Archimedes supposedly said, "Do not disturb my circles."
Oh, Archimedes.
Yeah, this soldier wasn't impressed, and well, he killed him.
That's a tragic end for such a brilliant mind. But at least his contributions to math lived on it.
Absolutely. But as we've seen, the story of mathematics isn't confined to just one place or one culture. It's this amazing journey that spans continents and millennia.
And where are we heading next on this mathematical world tour?
Let's travel east again to ancient China, where a unique and very sophisticated mathematical tradition was flourishing.
Okay, I'm ready to explore the world of Chinese mathematics. What wonders await us there, ancient China? I know they had a really unique approach to math. What set them apart from the civilizations we've talked about already?
Well, they developed this really sophisticated mathematical system that was incredibly advanced for its time. I mean, they even predated the West in using a decimal place value system by over 1,000 years.
Really?
Yeah, they used these things called bamboo rods to represent numbers.
Bamboo rods, okay.
Yeah, and they would arrange them in columns to show units, tens, hundreds, and so on.
So it's kind of like a hands-on place value system.
Exactly.
But the documentary mentioned that their written numbers didn't quite follow the same logic, right?
That's right. When it came to writing numbers down, they had these special symbols for tens, hundreds, thousands, and so on.
So like different symbols for each power of 10? That seems kind of complicated.
It was. It definitely made written calculations more cumbersome compared to using the rods.
Right. I can see how that would get tricky. Was this because they didn't have a concept of zero?
You got it. The lack of a symbol for zero in their written numerals made it really hard to represent place value effectively.
It's amazing how such a simple concept, like zero, can have such a huge impact on a whole mathematical system.
Absolutely.
But even without a written zero, the Chinese made some amazing mathematical discoveries.
Oh, yeah, tons. They were fascinated by numbers and patterns. One example is the magic square.
Oh, yeah, magic squares. I remember those.
Yeah. It's a grid of numbers where every row, column, and diagonal all add up to the same number.
It's like a mathematical puzzle.
Exactly. And there's this famous legend about Emperor Yu finding a magic square on the back of a sacred turtle. Yeah. It shows how much they believed in the mystical and symbolic power of numbers.
Wow, so math wasn't just a tool for them. It was like a reflection of their worldview.
Exactly. And they were able to apply their math to some very practical things, too. The documentary mentioned something about the imperial court, right?
Right.
Yeah. Math was absolutely crucial for keeping the empire running smoothly.
In what way?
Well, things like astronomy and calendar making were super important for the emperor's decisions.
Oh, okay.
You know, like determining the best dates for ceremonies or predicting eclipses. They even used math to manage the imperial finances.
I can see how that would be important.
Oh, and get this. They even used sophisticated math to manage the emperor's personal life.
The emperor's personal life? What do you mean?
Well, the emperor had a rather large harem,
Ah, okay.
and they actually used this intricate math system to schedule visits from his 121 wives and concubines.
Wow. That's a lot of scheduling. I guess even emperors needed a bit of math to keep things running smoothly.
Uh-huh, exactly.
Yeah.
But beyond all these practical applications, the Chinese made some serious contributions to theoretical math as well. Remember that ancient textbook, The Nine Chapters?
Yeah, the 9 chapters.
Right. It's this collection of practical problems that cover a whole range of topics, like trade, agriculture, taxes, engineering, you name it.
Sounds pretty comprehensive.
It was. But what's really interesting is its focus on solving equations.
So they were into algebra? What kinds of equations did they solve?
Well, one example is this problem about weighing plums and peaches to figure out their individual weights.
Okay.
It shows that they really understood systems of equations, which is still a key part of algebra today.
Wow.
And get this. The method they used to solve these equations was actually rediscovered centuries later by the famous mathematician Gauss.
That's incredible. It's like these ancient mathematical ideas traveled through time.
They really did. It speaks to this kind of universal nature of math. What other mathematical gems did the Chinese uncover? Well, there's the Chinese remainder theorem.
The Chinese remainder theorem. Okay, that sounds pretty complex.
It is a bit abstract, but I think I can explain it. Imagine you have a woman selling eggs at the market.
Okay.
She doesn't know exactly how many eggs she has, but she knows how many are left over when she divides them into groups of 3, 5, and 7.
Okay, so like the remainders.
Exactly. And the Chinese remainder theorem gives us a way to figure out the original number of eggs based on those remainders.
Wow. So it's like solving a puzzle.
Yeah. And while it might seem like a simple puzzle, it's got some really powerful applications. In ancient China, it was used to solve problems in astronomy, and today it's actually used in cryptography, which keeps our online information safe.
Wow, so an ancient Chinese theorem is helping keep our online transactions secure today? That's amazing.
Right.
Did they have any mathematicians who really pushed the limits of algebra even further?
They did. A mathematician named Xin Zhuxiao made some huge breakthroughs in solving cubic equations.
Cubic equation.
Yeah, those are equations that involve variables raised to the third power. He used a method of approximation that wouldn't be seen in the West for centuries.
Wow. He was way ahead of his time.
He was. His work shows just how deep and complex Chinese mathematical thought really was. But now let's shift our focus to ancient India, a civilization that gave us one of the most revolutionary ideas in math, the number 0.
0. It's hard to imagine math without it. So, from counting on our fingers to unraveling the mysteries of the cosmos, we've seen how math has been shaped by the needs and curiosities of different cultures throughout history. It's fascinating to see how these ancient mathematical ideas continue to influence us today, from the way we tell time to the algorithms that power our digital world.
What really struck me is how math is this truly universal language that transcends time and culture. It's a testament to the power of human ingenuity and our shared desire to understand the world around us.
Absolutely. So what stands out to you? What sparks your curiosity? Maybe this deep dive has inspired you to learn more about a particular culture or a mathematical concept. Whatever it is, keep exploring.